There is something hypnotic about high voltage plasma. Today, we are pushing this DIY Tesla coil kit to its limits to reveal its real power. I've got a nice manual, in Chinese only, thanks a lot. Anyway, Google translated it for me, and it's just a generic description and warning, nothing about assembly. Luckily, all SMD parts are already in place, so only THT components remain. I like to start with the simplest, most obvious parts first, the power switch and the power jack. It's interesting to know that this Tesla coil kit is a high-frequency resonant transformer that turns low DC voltage into high-voltage plasma arcs. Here is a simple breakdown how it works. DC power goes into the circuit. Our transistor RF250 rapidly switches that power on and off, creating high-frequency oscillation. This creates a high-frequency current in the primary coil, big one. The ferrite core helps concentrate and boost the magnetic field. That change in magnetic field induces a much higher voltage in the secondary coil. Because it's resonating at high frequency, the voltage builds up efficiently. At the top, the voltage gets high enough to ionize the air, creating a visible plasma arc. The vital player remained here is transistor. Knowing from the product photos how it should look assembled, there is only one correct orientation, no doubts here. Now applying thermopaste to the transistor. One last important thing, I couldn't find any dedicated connection for the fan, so I measured the only 3 vacant paths. They match the input voltage. I decided to solder the fan in parallel with the input. But keep in mind, the fan is rated for 24 volts, so anything over 30 volts will kill it for sure. For the first test, I used a 12 volts power supply. By the way, this kit includes an extra diode and ferrite that aren't needed for this specific configuration. At 12 volts, it barely produces a spark. Even so, I didn't like the cooling system. It's not efficient, even at low power. So I found 2 almost identical 24 volt fans in my drawer. I tested them in series at 40 volts and they work great. The fans are very close, that's roughly 4% difference, which is acceptable. The most effective cooling system is push-pull setup, so I made some simple mounting hardware. Now soldering 2 fans in series, meaning they should share the load, and connect this fan circuit in parallel with the input power. This setup is efficient and safe to run at 40 volts. The easiest way I found to mount the fans is by using grills. Simple and sturdy. Now everything is ready for the final test. I'm using adjustable power supply, setting up to 39 volts. Let's see how much power it draws when the Tesla coil is working. I tested it with a heat shrink tube. And just look at that, it burns easily. A small lamp lights up as well. But I have better idea. What about a bigger, regular size bulb? Let's try it. For a bigger bulb, I made a coil and soldered it to the bulb. And just look at that! It looks amazing! This sense is really fun to play with, and with my cooling update it's much safer. The fans are powerful, so the only parts that heats up are top coil and the arc coil. But the arc coil can be placed in front of the fan to cool it down quickly. Another advantage of wiring the fans directly to the power input, they keep cooling even when the PCB is switched off. And the last bonus! I found a small spring and put it in the arc. And just look at that! It's a really fun thing to play with. See you soon in the next epic idea.